All right, we're going to talk about a decision tree for evaluating limits in a calculus class. This process will be helpful for most exercises in a calculus class here in the United States. Before I start, let me just let you know some common exceptions to this decision tree. If you see anything that involves sine x over x, that's a good chance that you should not be following the decision tree. In general, when you're mixing trig with non-trig functions is a typical exception to this decision tree. And then also logarithms sometimes are not reliable for this decision tree. So these are common exceptions. For the most part, you follow this decision tree, you will get by in most calculus classes for most exercises in those classes. So the first thing you do is you will ask yourself what happens if I plug in the x equals a into that function. If you get a number, then you're done, and that's your answer. Including if you see 0 divided by a number, which is actually 0, then you're also done. Oftentimes students treat this like it's a separate case. To a mathematician, this is actually the same as this. If you see a number divided by infinity, then your answer is 0. If you see infinity divided by a number, then you're just going to use the rules of positive and negative to decide which kind of infinity. It's either going to be plus infinity or minus infinity, depending on the signs. So for example, a positive with a positive or a negative with a negative makes the end result positive, and if you mix a positive with a negative, it makes the end result a negative. So just follow your rules of arithmetic for positive and negative. Also, there are some useful facts as well. If you see log of plus infinity, the result of that is infinity. E to the plus infinity is also plus infinity. E to the minus infinity is 0, and then log of 0 plus is negative infinity. These are some common tricky ones. These all are in the category of, plugging in f of a and seeing what happens. It might not be clear what to do with the logarithms and the exponential functions. Now, a little bit less common, but also something that would be helpful to remember, is that arctangent of plus infinity is pi over 2, and arctangent of negative infinity is negative pi over 2. So these will be helpful when you're evaluating these limits, trying to sort of figure out what is this f of a business, and you see these strange functions. Trig in general can be tricky, and this decision tree might not apply to the trigonometry. All right, and then if you evaluate f of a or attempt to, and if you see one of these structures, then you need to do some sort of technique, and I'll list the techniques for each of the structures. So you might see a 0 over 0 structure, you might see a non-zero number divided by 0 structure, and you might see infinity over infinity. Now later in a calculus semester, you might see 0 to the 0 or 0 times infinity or some other very strange objects. These ones come later, and I'll make a separate video for those ones. If you see a 0 over 0 structure, there are 3 techniques in most cases. There's the factor and cancel technique, which is useful for when you have a polynomial divided by a polynomial. That's the most common example. Another technique is the conjugates, and this typically involves square roots and other things like that. Now, not every radical needs a conjugate, but the most common examples that involve conjugates are the radicals. And then the third technique is a technique that comes later in the semester in most classes, and I'll make a separate video on that. You need this method called L'Hopital's. If you see a number divided by 0, then you're going to do one-sided limits, and the final result is going to be either plus infinity, minus infinity, or does not exist. If you see infinity over infinity, there are sort of 3 common techniques for this. There's factor out the highest power of x and cancel, then see what remains. This is the technique that I recommend until you have the L'Hopital's technique at your disposal. The other technique is divide numerator and denominator by the highest power of x in the denominator. I do not recommend this technique for the most part, even though the beginning of the exercise tends to be easier than the other technique. So I recommend the technique where you're factoring out the highest power of x. It's a little bit tougher at the beginning of the exercise, but it simplifies the conclusion when you're ending the exercise, sort of wrapping things up and trying to get your answer. This technique that I recommend will actually simplify your conclusion. This technique down here, where you're dividing the numerator and denominator by the highest power of x in the denominator, is a little bit more difficult to keep track of the logical details at the very end of the exercise in a lot of cases. Not every case, but in a lot of cases, so I don't actually recommend it for students. And the third technique is L'Hopital's, and you'll do that later. Okay, now I will be making videos for every kind of example here. I already have some videos either uploaded or about to be uploaded that covers most of the basic examples. Instead of doing examples in this video, I just want to give you the overall lay of the land and sort of perhaps a consolidation.